Hello everybody, I'm Andy Pills. It's day 24 of our astronomy unit, and in today's lesson we started comparing our sun to the billions of stars that are in the universe. So one of my favorite astronomy quotes is that there are more stars in the universe than there are grains of sand on Earth. That's a whole lot of them. In today's video we'll be talking about some similarities and differences, mostly one really big similarity and one really big difference between our sun and all the other stars in the universe. And we'll do so by looking at a couple different diagrams and some practice Regents questions just to kind of make sense of what they call the evolution of a star or the life cycle of a star. Something to keep in mind, one similarity between all stars, is that they're not actually living things. What the similarity is that in every single star in the universe, the process of fusion is happening. Nuclear fusion is smashing lighter elements into heavier elements, and that's generating energy, and hopefully there's a planet orbiting that sun fortunate enough to get some of that energy and sustain some life. One big difference is going to be addressed in this very first question, so let's just jump right into it. So it says, base your answers on the diagram below, which shows two possible sequences in the life cycle of stars, beginning with their formation from nebula gas clouds in space. According to the diagram, the life cycle path followed by a star is determined by the star's initial mass and size, temperature and origin, luminosity and color, luminosity and structure. Well, this is an easy question because it says according to the diagram, and here's that kind of fork in the road, which is going to determine the path followed by the star. So let's just compare these two things, and we see that there's Earth's sun type star in the smaller star cycle and the massive star in the larger star cycle. So the best answer here would have been choice 1, mass and size. A lot of these other ones are kind of distractors. If you had an ESRT, you might have noticed this stars diagram, and it throws these words out, right? Temperature and luminosity, and it's trying to trick you into picking one of those. But the only difference between all of the stars in the universe initially is the mass. And the greater the mass, if you kind of think of our fabric of space lessons, the greater the gravitational well, and the more gravity, the more mass, the more fusion that would be able to happen in that star. Doesn't necessarily mean that these stars live longer. It just means that the amount of gravity that they can generate, and therefore the weight or the heaviest elements that they can make, are going to be greater. So let's keep on going. Number 2, stars like Earth, Sun most likely formed directly from A. So let's just make sure that we're using the diagram here, and a key word is directly. So here, Earth's sun type star formed directly from a nebula. Another space quote is that we're all stardust, and that's because sometimes when a supernova occurs, it's going to expel all of its gas and dust into space, or all times when a supernova occurs, that will happen. And some of that gas and dust is going to form a new nebula and complete this cycle and start it over again. That's why it's a cycle, because it's going to have the same repetitive steps in it. It won't ever go backwards, so it's always just going to be moving forwards in the cycle, but it can repeat. But since it's asking directly, the best answer here was nebula. 3, according to the diagram, let's get rid of that diagram, a star like Earth, Sun will eventually explode into a supernova, become a black hole, change into a white dwarf, change into a neutron star. Well, all of these choices were up here: black hole, neutron star, supernova. So the best answer here would have been a white dwarf for that one. Hopefully that was easy, just using the diagram. We'll take a look at that diagram a little bit more actually in this series of questions, and more so tomorrow. But here's another Regents Exam question. Again, similar flowchart, similar kind of algorithmic setup. So it's going to just bring us from one phase to the next. And based on certain factors, it's going to change the path that that star is going to follow. So number 40, the final stage in the life cycle of the most massive stars is. So here's the most massive, and we're just going to follow this to the end. We see that the very high mass are going to end in black holes, not black dwarfs, black holes, very high mass. 41, we're actually going to use the HR diagram. It's asking about which star may have once been similar to the sun in mass and luminosity. So if we kind of look at the path that our sun is going to take, because this question is related to this diagram, here's our sun. We know it's going to turn into a giant and eventually a white dwarf and eventually a black dwarf. So if we look at this diagram here, our sun is here. It's going to move up in this HR diagram in its intermediate stages billions of years from now as the giants. And then eventually in its later stages of its evolution, it's going to turn into a white dwarf down here. So we're just going to find which one of these choices would be either of these. And it appears that Procyon B is the best answer for that one. Lastly, 42, energy is produced in the cores of a main sequence star when. They love asking about fusion, and that would be lighter elements fusing into heavier elements. We're always going to see questions on gravity and fusion, the force of gravity, the process of fusion. Here's the same life cycle just being represented again. Here we just see it looks like our sun or an Earth's sun type of star because it's just turning into a giant and then a white dwarf. But all of that work just for this question, very predictable. The process, can even almost stop reading there, produces the energy radiated by the star when it becomes a main sequence star. That would be the process of nuclear fusion. Here it is again, same or similar diagram, same type of evolution that it's asking about. Let's take a look at these 4 questions. What determines if a star will turn into a giant or a supergiant in the intermediate stages of its evolution? As it goes from a main sequence, from a giant to a supergiant, the biggest difference is going to be its mass or its initial mass. What process must occur? That would be nuclear fusion, right? That's the very important process that occurs in all stars in order for a protostar to evolve into a main sequence star where fusion happens. Protostars, they still get really hot, they're really dense, but there's no fusion happening. The heat is just coming from the friction of all of the materials kind of squeezing together and getting compressed. Once it gets hot and the gravity is strong enough, when fusion happens, then we have a star. 4, what is the force responsible for an interstellar cloud of gas and dust to evolve into a protostar? The force of gravity. The word interstellar means like in between stars. So there's stars very far apart. Those interstellar, in between clouds, those are nebula. Lastly, let's just take a look at some of these questions describing the size of our sun compared to other stars. So you can talk about different stages because that's going to affect the size of the star. You can also talk about different masses. But you can even talk about how the size of the sun might change throughout the course of its life cycle or its evolution. Remember, it's not alive. Differences. We went over a couple differences in this video. And why won't every star become a black hole? Well, the answer is in these diagrams, and it's in your brain. So explain your thinking, and that's it. That's all I got. See you guys next time. Take care. Have a good night.